Hi everyone, today I'd like to talk about a new addition to AnalyseTool. This is a major update that allows you to create your own extensions. AnalyseTool itself is a C# plugin with a new WebView-based frontend. The frontend is built using JavaScript and TypeScript. With this update, you can add your own C# commands or create completely custom frontend application. The simplest example is AnalyseTool itself. It's essentially a WebView application that provides various tools for project analysis. You can create dashboards, Kanban boards, custom tables, and different ways of visualizing your data. For example, pages for checking empty elements, validating parameters, or simply browsing project information. This is just most basic example, so let's take a closer look at how everything works. Let's open the setting page. Here we can see information about the current environment, including the Revit version, SDK version, and plugin version. Below that, we can see all extension location. You can add your own path, such as OneDrive folder or a shared network location, allowing your entire team to use the same extension. We can also see all available extensions. Right now, the simple extension contains only UI frontend and no C# commands. On the Command tab, you will find all registered commands, including built-in AnalyseTool commands, as well as your own commands and commands provided by other extensions. Any command that meets the registration requirements will automatically appear here and become available for use. Another important part, they also a feature called C# code extension. This is currently experimental and allows you to execute standalone .cs files without building a complete project. If you'd like to experiment with it, you can enable it in the settings, but it's still under development. Another important feature is the MCP server. The MCP server works with the same commands used by front-end application. This means you can focus entirely on front-end development, entirely on MCP integration, or support both at the same time. Front-end applications and MCP service clients share exactly the same commons infrastructure. Commons contain attributes that define whether they are available throughout MCP. For example, you can allow Cloud to access specific commands or hide them completely. Now let's create our own command together along with a front end. For this example, I create an extension called a family control. One important requirement is that the extension ID must be unique. It's usually a good idea to use a company prefix or another naming convention to avoid conflicts. During creation, you can already specify the target tab, panel, or even button name. However, all of these settings can also be changed later throughout the manifest. There also a small preview showing what will be generated. Let's click Create. At the first, we'll get an error because the extension hasn't built yet and the required files don't exist. Now let's open the Generate C# project and create a simple command. We already have a sample hello command that implements a specific interface. This interface comes from AnalyseTool SDK. The SDK is distributed together with the plugin, but if necessary, it can also be installed separately through the AnalyseTool SDK package. The iRevit task interface is used for command registration. Any command implementing this interface automatically becomes available to front-end application. The same interface also provides access to Revit context. You can think of it as an alternative to external command, but built around external events. For convenience, let's continue the project so that after every build, the compiled DLL is automatically copied into the extension folder. That way we don't have to copy files manually every time. Let's build the project. Now we'll refresh the command list. As you can see, the command family control hello has appeared. Notice that AnalyseTool automatically generated the command ID using the extension's name and the class name. The class also contains a special attribute. Let's look at available properties. We have description is destructive, hidden from MCP, input type, read-only. Description provides information about the command. Destructive tells AI whether the command modifies the document. Read-only indicates whether the command is safe to execute. Hidden from MCP hides the command from MCP clients and integrations. And AI integrations. Input type helps AI understand the expected input format. Most of these properties are primarily used by the MCP servers and AI integrations. If you are not using MCP, in most cases description is all you need. Let's take a look at the command itself. iRevit task contains a single execution method that receives an iRevit context. Inside this method, we can execute Revit operation through an external event. The external event runs in the Revit context and allows us to safely access the Revit API. In other words, we can trigger an external event, perform operations inside Revit, and return the results back to the frontend. The frontend can then display the information, analyze it, or use it in additional workflows. Since everything is asynchronous, we can simply use await and wait for the result. For this example, we'll create a command that allows the user to select an element. We'll use pick object, let the user select an element, retrieve the reference, get the actual element, and finally obtain its element ID. Then we'll return the ID back to the frontend. The external event returns a long, while the comment itself returns an object, so we simply return the result as an object. And that's it, our command is complete. Let's build the project. Now let's switch to the front end. By default, it's a simple page containing a title, a button, some JavaScript code, and minimal styling. Let's modify the example so that clicking the button executes our element selection command. We will name the button pick element. Next, specify the comment ID and invoke in throat window.at.invoke. Let's click the button, the command starts running. I will select the wall and will immediately receive the element ID of the selected wall. As you can see, everything works. Using this approach, you can create as many custom comments as you want. You can build complete front-end application yourself, use AI to help generate them, or create sophisticated dashboard-based analyze tools. The same comments can also be exposed through the MCP server and used directly from Cloud or any other MCP-compatible AI client. In this scenario, you may not need a frontend at all and can focus entirely on building C# commands for AI-driven automation. I'll be interested to hear your thoughts. Would this be useful for your workflows? Do you have any ideas or suggestions for improvements? Let me know in the comments. Thanks for watching, and I will see you in the next videos.